going to do here is to solve this Unit 4 paper question on rates of reaction, which I found to be very tricky. We're going to use a method that you can use for any rate equation, for solving any rate equation. So if we write a general rate equation for this reaction, we can see that the rate is equal to the rate constant multiplied by the concentration of reactant D, and we'll raise that to the power x. That's what we're trying to find, the order with respect to the concentration of D, multiplied by reactant A, concentration of E, and we still don't know the order of reaction with respect to E, so we'll give that a value y. Now, in order to get rid of this pesky constant, we can use simultaneous equations, because since that doesn't change, we can say, for example, let's choose two experiments. Let's choose experiments 2 and 3, because conveniently in experiments 2 and 3, the concentration of D has been kept the same and the concentration of E has been varied. So immediately we know we should be able to solve the order with respect to the concentration of E, the effect of changing the concentration of E, what effect does that have on the rate. So what we do is we choose experiments 2 and 3. Since the rate is larger in experiment 3, we're going to put that one on the top. So we'll say that the rate in experiment 3 divided by the rate in experiment 2 is equal to the rate constant divided by the rate constant, that will cancel out, multiplied by the concentration of D in experiment 2 divided by the concentration of D in experiment 3. Concentration of D in experiment 3 divided by the concentration of D in experiment 2, so power x, multiplied by the concentration of E in experiment 3 divided by the concentration of E in experiment 2, so power y. Now immediately, because the concentration of D in experiment 3 and experiment 2 is the same, that cancels out conveniently as well. So now what we can do is put the values in. So the rate in experiment 3, the initial rate in experiment 3 is 1.57 times 10 to the minus 1, 1.57 times 10 to the minus 1, divided by the rate in experiment 2, which is 3.92 times 10 to the minus 2. The concentration of E in experiment 3 is 1.75, divided by the concentration of E in experiment 3 is 8.73 times 10 to the minus 1, raised to the power y, because that's the order that we're trying to find. Simplifying this, go to your calculator, that comes out to approximately 4, and that comes out to 2 to the power y. So therefore y must be 2, 2 squared is 4, so therefore it's second order with respect to the concentration of E. What we can now do, now we've deduced that it's second order with respect to the concentration of E, is go back to our simultaneous equation again and choose two different experiments. You can choose any two experiments because the concentration of D and E are being varied. So for argument's sake, let's choose experiment 1 and experiment 3. We're going to substitute everything into this equation. So the rate in experiment 3 is 1.57 times 10 to the minus 1, and the rate in experiment 1 is 1.16 times 10 to the minus 2. Let's just remind ourselves, so we're going to compare experiments, just in case I forget, 3 and 1. Again, we've cancelled out the rate constant, the concentration of D, let's write this down, in experiment 3 and we still don't know the order with respect to D, divided by the concentration of D in experiment 1, multiplied by the concentration of E